in this lecture, we are going to discuss the various protocols which are needed for IoT system. Okay. Uh, so as you know, there are various layers of IoT, and here on screen you can observe the various types of protocols which have been used in different layers. Okay, so we are going to discuss these one by one. So if you are coming to link layer is nothing but your physical layer of data communication, and it involves the communication basically. If it is wired, it will be over twisted pair cable or coaxial cable, and if it is wireless, then it is with help of radio waves. Okay, so this link layer basically manages communication between the device and host. Okay, so communication between device and host is carried out here. So these type of protocols generally they involve both wired as well as wireless type of protocols. Okay, so here as you can see in this particular diagram, so this is the link layer, and in this link layer you can observe IEEE standard 802.3. This is a wired Ethernet protocol. So generally this is a wired Ethernet protocol, and here the medium shared is the twisted pair cable, coaxial cable, or optic fiber cable. Okay. Uh, so data rate, it may vary depending on your type of Ethernet, base 5, base T, and base F Ethernet. We know all these, and it has different type of data transfer rates, namely 10 Mbps, 100 Mbps, and Giga network is also there. So all these can be used for wired communication. Okay, so now if you go for wireless communication, then in that case, for wireless communication, the IEEE standard which is used is 802.11. Okay, so generally two types of wireless protocols are used. One is all of you know Wi-Fi, and another is WiMAX. Both they follow same technology, but there is a little bit difference between them. Okay, so 802.11 is a protocol for wireless local area network, and almost the data rate starting from Mbps to Gbps, 1 Mbps to 6.7 Gbps. This range of data rates can be achieved with help of this 802.11 Wi-Fi protocol. So 802.3 is Ethernet protocol, 802.11 is a Wi-Fi wireless protocol, and there is one more protocol which is called as 802.16. This is called as WiMAX. WiMAX is a improved version of Wi-Fi, and WiMAX particularly is used for broadband wireless communication. Okay, so the improvements of WiMAX over Wi-Fi are basically its high speed and larger distance coverage and greater number of users. So this was objective of the WiMAX type of standard. So if you want a greater range of wireless communication, if you have more number of nodes to be connected together, and if you want more data rate, then in that case, you can use the WiMAX type of protocol for communication in Internet of Things. Okay. So even here, smart object protocols you can observe over here. So here you can see IEEE 802.15.4e. Okay, So these generally are the type of the networks which are called as low rate wireless personal area network. Low rate wireless personal area network, that is LRWPAN. So they are having a smaller data rates. So depending on application, we can use this type of uh, protocols here. This basically LRWPAN, it has low power, low speed, and low cost. Okay, so wherever low power consumption is required, then you can use it, but with cost of low speed. Okay, but it is also low cost. So for simple applications, you can use such type of devices. Okay, so now, apart from your Ethernet, Wi-Fi, WiMAX, and LRWPAN, mobile communication can also be used. Mobile communication can also be used. So here for mobile communication, you can use 2G, 3G, and 4G standard. And the protocols which are used for 2G, as you know, they include GSM and CDMA. And for third generation, the standards which are used are UMTS and CDMA 1000. And for fourth generation, as you know, it is LTE. Okay, so nowadays fourth generation LTE is available with the data rate, larger data rate as compared to 2G and 3G devices. Okay, so any of these, even 2G, 3G, and 4G, any of these protocols can be used. So mobile communication protocols can also be used in order to connect the um, end users or nodes to the host. That is what we can say here. So here, what is important from examination point of view is you have to remember the different layers and the protocols which are used in different layers. Those need to be remembered. Okay, so nothing else. Now, coming to the network layer, which is also called as internet layer. So this particular layer, network layer, or it is also called as a internet layer. So this layer basically handles sending and receiving of the packets over a network, okay, from source to destination. So generally, packet type of communication, that is whatever information you are getting, that is converted into packets, and these packets are delivered from source to the destination in this particular layer, which is called as a network layer or internet layer. So these layer generally, three types of protocols are used, as you can see here: IPv4, IPv6, and 6 low WPAN. So these are the protocols which are used in this layer. IPv4 is nothing but Internet Protocol version 4. It is basically the addressing scheme used for identification of the devices over a network. All of you know this IP address. All of you came across this word. So IPv4 has generally a 32-bit header. So that means address is 32-bit wide. So 2 to the power of 32, those much of devices can be connected by using this IPv4 protocol. So improved version of IPv4 protocol is IPv6 protocol, which is called as version 6, which is successor of this IPv4. That is what you can say. So here, what has been done, it is very similar to IPv4, but the number of bits in the header is increased from 32 to 128. So at this time, 128 number of bits are used. So address which is used to identify the device is 128 bit wide, and as the number of devices those can be connected in a network depends on the width or length of the address. So it is having 128 bit wide address, it can it can connect 2 raised to 128 devices using this IPv6 type of protocol. Okay, so both of these IPv4, IPv6 can be used in the network or internet level layer. Okay, so the third protocol which actually deals with the smart object protocols, they are called as smart object protocols, and here you can see six low WPAN type of protocol is used. Meaning of 6 is IPv6. Okay, low means over low power, and personal area network. PAN means personal area network. So this is basically designed for low power devices. Okay, so devices with low processing and communication capabilities use this type of protocol in a network layer. So generally, this operates at a range of 2.4 gigahertz, and all of you know 2.0 gigahertz is license free ISM band. Okay, and the data transfer rate provided with help of this is almost 250 kilobits per second. Okay, so this standard, as we have seen earlier, it is 802.15.4. Okay, in a link layer. So that is what we have seen. Okay, so in link layer, it works together, and it is also going to describe the compression type which is used for the communication in this particular low PAN type of protocol. Okay, so what you remember about this is the only thing is that it is used for low power devices. It is a version of IPv6, and it is used for personal area network. That means its range is also limited. Okay, personal area network means it is limited range. Now, coming to the transport layer, which is our third layer, basically this transport layer manages the end-to-end communication irrespective of the network that you are using. Okay, so these transport layer basically defines the type of the communication. Okay, so and it is also going to define error correction, error detection, segmentation of the packets, even congestion control, flow control. All these things are managed by your transport layer that you know well. Okay, so basically two types of protocols are used here. One is TCP and another is UDP. So all of you know TCP and UDP. So while studying, I think Bluetooth, we came across this. TCP is a transmission control protocol, and it is a connection oriented protocol. That means initially the connection has to be established in order to deliver the packets. So without establishing communication, without establishing a link, the communication cannot take place. Okay, so this protocol is generally used by your web browsers, email programs for file transfer, etc. Now, as you can see, it also provides error detection, error correction technique, flow control technique, etc., congestion control technique to avoid jamming. Okay, so this is connection oriented, link has to be established. It is slower as compared to its another core protocol, which is UDP. UDP means user datagram protocol. And in contrast to TCP, this is a connectionless protocol. There is no need of establishing link between source and destination. So as there is no need of link, the UDP will directly communicate between your source and destination, and therefore it requires less time. So as this is faster, but reliability is less because we don't know whether link has been established or not, and therefore it doesn't guarantee the packet delivery. So this is what is its disadvantage, but otherwise it is a faster type of the protocol. Okay. Now let us go to what is called as application layer protocol. Okay. So if you consider application layer protocol, in this case, you can observe HTTP, FTP, SMTP, COAP, etc. These various types of protocols are available here. So as you can see, HTTP is the application layer. Basically, what is use of application layer? It manages how the lower level protocols and application interface will be communicating for sending and receiving of the data. Okay, so this applications usually use files transfer mechanisms, and these files are encoded by the application layer and compressed by the transport layer protocol for communication in the network. So this is what we have seen here. Okay, so the first type of protocol that is used here, HTTP, all of you know this HTTP. The long form of HTTP is Hypertext Transfer Protocol. And this is actually base of your www, and this HTTP protocol commands are used for data communication by your application. So various commands like get, put, post, delete, they are used for communication. Okay, so this is what is your HTTP protocol. Okay, now coming to another protocol, which is COAP, that is Constrained Application Protocol. Basically, it is used for machine-to-machine communication. COAP, as it exists in Smart Objects Protocol, you can observe in the diagram. It is machine-to-machine communication protocol. Okay, so this is basically used for a small embedded system and controlled environment and constrained network. So it is basically used for small type of network, and it uses client server model for communication. So that is what you can observe over here, and it is very similar to HTTP, and it also provides commands just like HTTP: get, put, post, delete, etc. Okay, now still more other type of protocols are present here, so which you can see over here. Apart from hypertext protocol, LoraWAN protocol is used, Bluetooth protocol is used, Zigbee protocol is used. Now, if you consider for data transmission, message queue telemetry protocol is used, okay, for collecting data from various electronic devices. Okay, so such type of protocols are used. Even XMPP protocol is also used. Constraint application protocol, just now we have discussed about. AMQP protocol, this is also used for message oriented middleware environment. Okay, so this provides routing, queuing, and point to point connection. Okay, so these number of protocols are used for communication. So most of them are listed over here. You can read from this. And XMPP is also there, extensible messaging and presence protocol. Okay, so this is basically used to exchange the messages. So this also uses client to server and server to client server communication type of model. So this is basically used in the streamed networks. Okay, so this type of protocol is used. So all these number of protocols you should know about. So in which layer which protocol is used, which is used for networking and which is used for your data communication. So this thing you want to know about this, and again go through your multiple choice questions. Okay, so that is very important over here. Okay, now after this After discussing the protocol, what we need to discuss about Internet of Things is, as per your syllabus, what is given here is the cross connectivity across IoT system components. Cross connectivity across IoT system components. That is what is written over there. Okay. So, and this cross connectivity is a term which define connection between all the points in IoT ecosystem. Okay, so what are the different points? The different points are device, cloud is there, gateways are there. So communication between these are nothing but cross connectivity. Okay, so basically these are connectivity models. Okay, so in technical world, if you learn this, if you access some learning material, then you can observe that this particularly is called as a Internet of Things connectivity models. But in our syllabus, it is given cross connectivity across IoT system components. Okay, so meaning of both is the same. So it is Internet connectivity model only. Okay, so now here, as there are four such models, you can see one is device to device, another is device to cloud, device to gateway, and last is the backend data sharing. Okay, so these are the some of the models. Okay, so backend data sharing is also called as device to cloud. Okay, directly device to cloud. So it is also called as backend data sharing. So you remember this. Now the first type of communication model is device to device communication model. Okay. So this represents two or more devices that are able to connect directly with each other. Okay. So they are communicating with each other with help of different types of networks. Okay, or internet also. So mostly used protocols for this device to device communication. They are Bluetooth, Z-Wave and Zigbee. Okay, so these three types of protocols are used for device to device communication. Basically, the application in which such kind of communication model is present is simple application systems like your home automation system. Okay, so here the data or information is exchanged between the devices with relatively low data rate. Okay, so your different devices, maybe your lighting system, your thermostats, door lock, etc. So basically for home automation, this device to device connectivity model of Internet of Things is employed. Okay. So now for this, as you are using it within home, the short range communication protocols are suitable for this. And we have studied which are short range protocols, and the short range protocols are Bluetooth, Z-Wave and Zigbee, and all of these are used here. Again, yeah, if you take a wearable device, then this application again uses this kind of device to device communication model. Okay, so basically the low energy Bluetooth is popular here because of its low power requirement. Okay, instead of your simple Bluetooth, Bluetooth version 4 plus, that is your low energy Bluetooth, it is used in this type of communication. Okay. Now moving to second type of communication model or cross connectivity, that is what we can say, is device to cloud connectivity and device to cloud communication. So this involves Internet of Things connecting directly to your internet cloud. Okay. Uh, like as we have seen for what the cloud is used. Okay, So cloud connectivity can be used for infrastructure, for maybe for network, for storage, for sharing software, for sharing platform, etc. So in this case, cellular based device to cloud type of communication can be used. Okay, so this is all about device to cloud type of communication. So here devices are connected to cloud, and devices are not communicating directly, but they are communicating through cloud. Okay, so this is what device to cloud type of connection model. Now let us see what is device to gateway model. Okay, so here you should know what the gateway is. Okay, so in case of IoT, what the gateway is. As you can see over here, the gateway is present between the two things. So IoT devices are there, data systems are there, and these two things are connected with each other by a thing which is called as a gateway. So it provides a bridge between different types of technology. If you consider devices, they are following different technology. If you consider data system, they are following a different technology. In order to connect these two different things together, you need something in between to bridge this gap. And to bridge this gap, component is used, and that component is called as a gateway. Okay, so IoT devices connect to IoT gateway. So various kinds of again protocols are used here. Okay, so let us go back to our communication model, that is device to gateway. So here devices are connected to an intermediary device, okay, to access the cloud service. And basically this intermediary device, it may be a smartphone. Most of the times the smartphone is used to as an intermediate device, or even hubs are used as intermediate device. Okay, so those are going to connect IoT device with a cloud service. Okay, so why to use this type of communication model? Because it can provide security and other functionalities such as data or protocol translation. Obviously, gateway is responsible for protocol translation, because two different types of things has to be connected together. Okay, so actually this intermediate device is nothing but a application software that is present in your smartphone, and that application software which is present in your smartphone, it is working as a gateway. Okay, so again you can take example of your wearable device here, fitness device here, which are using this device to gateway type of communication. And for this communication, it is, as I told you, it is using short range communication protocols like Z-Wave, Zigbee, even Bluetooth also. Okay, now after this we are going to the fourth type of communication, which is backend data sharing. Okay, backend data sharing means it is directly device to cloud communication. Okay, so IoT devices, which are you can say sensors, they can be directly accessed by your authorized third parties. That is your cloud operators, you can say cloud providers. So under these models, user can export, analyze smart objects data from a cloud service in combination with the data from other sources. Okay, so this is what is the basic model provided here. So as compared to device to gateway and other models, this backend data sharing model is advantageous. It is efficient. That is what you can say. Okay. So this is all about the cross connectivity across IoT system, IoT system components. Okay, or IoT connectivity models or IoT communication models. So meaning of each thing is the same. Okay, so as an information I have given this cell phone as a gateway, how it can be used as a gateway here, but it is not in your syllabus, so there is no need to go for it. Okay, now we are moving to the network technologies, various types of network technologies which are used in Internet of Things. Okay, so basically the network technologies which are used in IoTs are they are low power network technologies. Okay, if you consider local area network, wide area network, okay, or even personal area network. So all these networks, they are of low power or low energy type. Okay, so if you consider um, low power local area networking, basically they are used in applications for home or office where the area is restricted, a small range of area is there. So in that case, low power local area networking is used. So for home applications, low power personal area networking can also be used. It depends on a particular application. But what is important is the low power wide area networks. Okay, as it provides the long range communication, and still it operates on batteries, inexpensive batteries, because all are mobile applications and they require batteries to power, and power which is used from this battery, it must be as much low as possible to increase the life of battery. So that is what is main objective is here. Okay, so these wide area network, they provide long range communication. They have smaller data rate. They have low power consumption. They have good battery life, and still they are providing better connectivity. So various types of these low power wide area networks or different technologies which are providing this low power area network, they needed to be discussed in short. So the various low power wide area network technologies which are given in your syllabus, they are LoraWAN, then I think Scifox is given, NB-IoT is given, and CATM is given. CATM is related to your LTE. Okay, so these things we are going to discuss over here. Okay, so if you come to this type of network which is called as a Scifox. Okay, so this is a wide range technology. Okay, its range particularly is comparable to your Wi-Fi and cellular range. It uses your ISM band, which is license free band. Uh, so it is capable of transmitting over a very narrow band spectrum, and it can be used to connect the objects. Okay, Basically, Scifox was discovered for your machine-to-machine application, and it is intended for small battery. Only low level of data transfer is required here. Okay, and it uses what is called as UNB, that is ultra narrow band. So ultra narrow band is used here. That means the bandwidth of the uh, you are using for communication is very small. Okay, and this uses by bipolar phase shift keying type of modulation. So phase modulation is used here. So here, as you can see, various parameters of this Scifox. Frequency at which it is operating is 900 megahertz, and range we can obtain 30 to 50 kilometer in rural environment, and 3 to 10 kilometer in urban environment. Okay, so it depends on the density, and data rates from 10 to 1000 bits per second. Okay, 10 to 1000 bits per second. So this is what you have to remember about the Scifox. Okay, now coming to next type of low power technology, which is also called as a LoraWAN. Okay, so LoraWAN, meaning of this long range uh, wide area network, long range wide area network. Okay, so this is similar to your Scifox, which is designed for low power, and it is used for machine to machine communication, and various types of applications which are used by using this technology. They basically may contain industrial applications as well as smart city applications. So IoT is deployed for smart city applications and industrial applications. They are using LoRaWAN, and this LoRaWAN is very very important as far as your Internet of Things is concerned. So various frequencies are available there, and range, if you see, for urban areas it is 2 to 5 kilometer, because more density is there, and 15 kilometer in suburb areas. Okay, so data rate you can have up to 50 kbps. So these are the features of your LoRaWAN technology. Now, if you observe this figure shows the architecture of the LoRa technology, and this LoRa technology works in four layers. The first layer is end node layer. Second layer is gateway, which is also called as